Today we're looking at trig functions of special angles and drawing the angles of 30 degrees, 150, 210, and 330 on the unit circle. We can find some neat patterns. All of these angles have the same reference angle. Which means that they're the same distance from the x-axis. Okay, so they all have a 30-degree angle away from the x-axis. And plugging into your calculator, as long as I'm in degree mode, if I find sine 30 and change it to a fraction, it's 1/2. Sine 330 is also a half but negative. Sine 210 is negative a half as well. And sine 150 is a half. So because these all have the same reference angle, they all have the same ratio, how do you know which one is going to be positive or negative? Using the cast rule. All students take calculus. Sine is positive in quadrants 1 and 2, and sine is negative in quadrants 3 and 4. And what's cool is we can actually take this information and make triangles. We know that sine is opposite over hypotenuse. So if sine is 1/2, that means that the opposite could be 1 and the hypotenuse could be 2. Then sine would be a half. Which kind of makes sense because if I've got two 30-degree triangles, that makes 60. This angle would be 60, 60. So I have an equilateral triangle. All the sides are 2. Now technically that's not a unit circle anymore because I made the radius 2 instead of 1. But if I wanted to, I could scale all those points down by a half. So all of these angles have the same ratio, but just different signs. Okay, so for some special angles and multiples of these angles, it's possible to calculate exact values of trig ratios. And basically there's 2 different triangles. And I drew 3 of them for you there. So let me put that into my notes. But really, triangle 2 and triangle 3 are the same triangle. Just rotate it. So do you remember what pi over 4 is in degrees? 45. So if this one's 45 degrees and this is a 90-degree angle, do you know what the top angle is? 45. This is called an isosceles triangle. So if it has 2 equal angles, it's also going to have 2 equal sides. And because sine and cosine and tangent are just ratios, it doesn't matter what size the triangle is, the ratio will always be the same. So I can pick any random number that I want for those 2 sides. My favorite number is 1. So I'm just going to say that this side is 1 and this side is 1. Because that's the easiest. And then I can use a squared plus b squared equals c squared to find out how long the hypotenuse is. 1 squared is 1, 1 squared is 1, 1 plus 1 is 2. So c is the square root of 2. So if the sides are 1, then the longest side is root 2. So sine is opposite over hypotenuse. or 1 over root 2. And in grade 10 you had to rationalize the denominator. I'm not going to ask you to do that, just so that you can more easily connect this to an idea of a triangle in your head. Cosine is adjacent over hypotenuse. So that's also 1 over root 2. And tangent is opposite over adjacent, which is 1. So tangent of 45 degrees is always 1. So if I had chosen the side length, my favorite number, to be 7, then both of the sides would be 7 and the hypotenuse would be 7 root 2. So tangent would be 7 over 7. It's still equal to 1. Doesn't matter how much I expand that triangle. That's why I could pick the number 1 for my adjacent and opposite sides. It just makes it the easiest number. Now, do you remember what pi over 6 is in degrees? 30. So that's a small angle in this triangle here. And that's the one that we saw up on the first example. If you have a 30-degree angle, then what you can do is you can copy and paste that triangle and just make an exact image of that triangle right below. That is also 30, so that the total angle is 60, 60, 60. And then I have an equilateral triangle where all the 3 sides are the same. This side, and this side are all the same. So I can pick my favorite number for that side. And I'm going to call that side 2. Because this side here is half as long as that hypotenuse. Because when I put 2 of those pieces together, I get 1 part of the equilateral triangle. So then that number will be 1. So if I pick my longest side to be 2, then I don't have any fractions or anything. Does that make sense? Okay, once you know those 2 sides, you can use a squared plus b squared equals c squared to find out what the third side is. So a is 1. I don't know what b is. C is 2. So 1 plus b squared is 4. So b squared is 3. So that means that b is root 3. This side here is root 3. And this is what I like to call my 1, 2, 3 triangle. 1 is the shortest side. 2 is the hypotenuse. And 3 is the longest of the 2 legs. So sine, using a 30-degree angle, sine is opposite over hypotenuse, so 1 over 2. And that's where we got the 0.5 from the first example. Cosine is adjacent over hypotenuse, so root 3 over 2. In your calculator, you'll see this answer is 0.866. If you see 0.866, then maybe you can recognize that as root 3 over 2. And tangent is opposite over adjacent, so 1 over root 3. Now pi over 3 is 60 degrees. Really, this is the same triangle, just rotated. So this is my 1, 2, 3 triangle. Shortest side is 1, hypotenuse is 2, longest side is root 3. 1, 2, root 3. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So really the 30-degree triangle and the 60-degree triangle are kind of the same triangle. Are there any questions? Okay, on the back side, we have a review from last time. Okay, so you can fill in that information about the quadrants from your last class notes. The most important is that you fill in the all students take calculus. And the sine, cosine, and tangent, you can fill that in with the x, y's, and r's. On the top right corner where it says sine theta, cos theta, tan theta, you can put in y over r for sine theta. And using the diagram that's on the left, you can fill in all the x, y's, and r's there. And then using your all students take calculus, you can fill in the chart with the quadrants, just with positive and negative signs. So the definition of a reference angle is the angle from the terminal arm to the closest x-axis, and we want to be able to find the exact value of a trig function for any multiple of 45 or 30 degrees. So the key to doing this is to draw a diagram, find the reference angle, use the trig function from the reference angle, and then just apply cast. And I'll show you another method to do this as well. So for the first angle, I'm just going to try to draw this out on my diagram. Because it's in radians, I can use a nice trick. I don't want to switch it to degrees because this is going to go a lot faster if I use radians. Over 3 means that this is some multiple of 60 degrees. I don't like counting out by 60 degrees. That's complicated. So I'm actually going to change this to a fraction with a reference angle of 30 degrees instead. That's much easier. So do you know how I can change the numerator? Multiply by 2. It's the same as 14 pi over 6. So I always write my angles in terms of a denominator of 6 or a denominator of 4. So that means I've got 14 third of quadrants. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 pi over 6 is right here. So when you see the over 6, or sorry, the over 3, anytime that you have something in radians with a 3 in the denominator, that tells you the reference angle is 60 degrees. So it's a really nice and easy way to see the reference angle, which you can also see in this picture. So now I know that when I have a 60-degree angle, that this is my 1, 2, 3 triangle. Anytime that you have a 60 or a 30-degree reference angle, it's your 1, 2, 3 triangle. The 1 is the shortest side. The 2 is the hypotenuse. And the root 3 is the medium, longer leg. So you just need to memorize that the 1, 2, 3 triangle goes with 30 or 60 degrees. And now I just use my sine is equal to opposite over hypotenuse. Sine is equal to opposite over hypotenuse, which is root 3 over 2. Ta-da! That was hard. I find that doing this in degrees is a lot more difficult because I have a harder time finding the quadrant. So if I'm going negative 135 degrees, That means I'm going clockwise. I think that is 45 more than 90. So I'm 45 degrees more than 90. And then I make a triangle using the x-axis. So the reference angle is 45 degrees. If it's 45 degrees, that means I've got two same angles, two same sides. I'm going to name them both 1. The longest side is root 2. That's the only other triangle I need to know. Anytime you have 45 degrees, this means you're looking at the 1, 1, root 2 triangle. And now I've got to put on my positives and negatives. Now the radius is always positive. On the x-axis, I'm on the negative side, so that means my 1 is negative. On the y-axis, I'm below ground level, so that means my y-coordinate is also negative. And that's because I'm in quadrant 3. So cosine is equal to adjacent over hypotenuse. Adjacent side is negative 1. Hypotenuse is root 2. Ta-da! No calculator needed. Now you try tangent. So to solve tangent, because this is in radians, the denominator is 6. That means I'm looking for 19 30-degree angles. And that denominator of 6 actually gives me the reference angle. So nice. So I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 30-degree angles. And then I make a triangle with the x-axis. And I know that if I have a 30-degree reference angle, I'm looking at my 1, 2, root 3 triangle. 1 is the shortest side, 2 is the hypotenuse, root 3 is the longer of the two legs. I put in my negative signs where I need to. And tangent is opposite over adjacent, or 1 over root 3. So the 1 is negative, the root 3 is negative, so those two negatives cancel. Okay, and I can also use CAS to do that. All students take. I know that tangent's going to be positive there, so that just confirms that my answer is correct. I'll count what? So the next few examples are overlap with what we did last class. Here we're given a tangent ratio, negative 8 over 5. And using my y equals x, I know that means that y is negative 8 and x is 5, or y is 8 and x is negative 5. So that negative sign can go on the top and the bottom of the fraction. Now, it tells me that I'm in quadrant 2. In quadrant 2, y is positive, but x is negative. So that means I must be looking at this for my tangent. So now it's asking me to find the coordinates of a point M on the terminal arm. So if I have a triangle there, what might the points M be? Negative 5 for x, 8 for y. That's it. Now that point's not on the unit circle. If you wanted to put that point on the unit circle, you'd have to divide by the radius. Example 3, if we're given a point, x, y, on the terminal arm, find the value of sine, cosine, and tangent. Tangent's easy. -3 over -5, or 0.6. Okay, given a coordinate point, you're given the tangent value. To find sine, I need to know what the radius is. So I've got to use x squared plus y squared equals r squared to find the radius. 25 plus 9 is 34. So r is the square root of 34, and it's always positive. And I just put in my value for y. And cosine is x over r, so -5 over root 34. And you can find out cotangent and secant and cosecant just by flipping the fractions over. No, and don't rationalize the fractions, please. Ooh, some harder questions. So for example 4, if you're given the coordinate point, you can already know one of the ratios. Do you know which one? Tangent. So this means that tangent theta is 4 over 4 root 3. -4 root 3, thank you. So if I simplify that fraction, it's 1 over -root 3. Does this give you any goosebumps? It's the 1, 2, 3 triangle. What's the angle that goes with that triangle? That's the 30-60 triangle. So now I can draw that quite confidently. There's two possibilities, actually. This means that either y is 1 and x is -root 3, or y is -1 and x is root 3. So let's see. That means that y is the short side of the triangle. So y is my smaller one. So that means I'm looking at +1 and -root 3. Or y is negative, y is short. Draw the triangle always with the x-axis. So y is negative, x is positive. So there's my two possibilities.
Isn't there only one possibility you sort of see that x is negative?
Oh, yes, right. Thank you. Silly me. It says that x is negative, so it has to be quadrant 2. This is not a possibility. I could have drawn that right from the beginning. But I wanted the force to cancel off. And that's why I was looking at the tangent ratio. So in standard position, well, we've got the reference angle of 30 degrees. So that means that my standard position angle must be 180 minus 30, or 150 degrees. There will be one question like the next one on your test. And these questions always seem really tough when you see like m's and n's. But just take it apart part by part. When it says that m is greater than 0 and n is greater than 0, basically this is telling you which quadrant you're in. So if you're given a coordinate point, and both the coordinates are positive, do you know which quadrant that is? 1. So that means I'm just looking at a point in quadrant 1. So now it's asking me to find the value of sine pi plus theta. What is the pi doing there? The pi is just saying it's an angle in radians. Do you know what pi represents in radians? 180 degrees. So if this is theta, it's asking us to find out what is sine if we take theta and add 180 to it. Do you know which quadrant that angle is going to end up in if I add 180 to it? Quadrant 3. That's just going to turn it into a straight line. So I'm just taking 180 more. Do you know what the reference angle is? Doesn't change. The reference angle is still theta. So here n is the height, m is the base. On this triangle, it's a similar triangle. It still has m and n. Which one of those two is negative? Both of them, right, is quadrant 3. I'm in the negative part of the x-axis and the negative part of the y-axis. So sine of that angle is y over r, which is negative n over, what's r? R squared equals a squared plus b squared, or x squared plus y squared. So negative n squared plus negative m squared. So that's why we've got this craziness in the denominator. R is the square root of m squared plus n squared. Ta-da! Okay, so this is just a fancy way of saying y over r. So that's one of those questions when you look at it at first, it looks like it's written in Greek, and you wish you had a translator. And then when it gets translated, it seems a lot easier. And now for some practice review from last time. If you're given an angle of 2,000 degrees, to find the coterminal angle, you just can subtract 360 until you get down to the smallest positive angle. The nice thing about this is that if you do answer minus 360, then you can just hit enter, 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 and it gives you a sequence. And all those angles are coterminal. This is a shortcut. You just keep going until you get the last positive one, which in this case is 200. Okay, and for negative 5100, you could just add 360 until you get a positive number. Just take my answer plus 360, and then I can just go enter, 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 until I get a positive number. And all of those angles are coterminal. So 200 degrees is just a little bit more than 180. The reference angle is how much more it is than 180. So that would be 20 degrees. 300 is just a little bit less than 360. So the reference angle is how much less is it than 360. And there's no special angles for those ones. Or, I mean, for the first one. So 20 degrees doesn't have a special angle. There's nothing really that you could do to find out that ratio except for plugging it into your calculator.